So today we'll be learning more things about BI, um, basic concepts about what BI is and what it can and what it can do beyond just making fancy dashboards. And we will also learn a little bit about Looker. And the hands-on session is focused on Looker. So in Mercari, um, we use Looker as our visualization tool and also like data modeling tool. Um, Similar tools in this space will include Tableau, Power BI that you might have heard of. So before we begin, I would like to say thank you to all of the teams behind making the Dev Dojo happen, which includes engineering growth and experience team who put together Dev Dojo, and global operations team who are translating the Dev Dojo session at the moment, and the other tutors who contributed to the Dev Dojos, and AI, of course. So some of the slides and the images that you see here are generated by AI. So we are living in an era where we can visualize things that always try to imagine visually, and we are able to interpret all of those things in the images. And also, I am thankful to AI so that when AI takes over the world, I'll be on the good side. And oh, and how can I not thank my team? So this is JB Data. Um, and so all of these happy faces are from JB Data. This is from a recent offsite that we had. And so, yeah, we are trying to make data accessible to everyone at Mercari. And so far in our team, what I've noticed is like this is like a university. This is my third year here, and every single day I'm learning new things and working with new tech. And I'm pretty sure that all other teams are like that in Mercari, and hope you have a great time here. And I'm Satya Sarthi Gunashekaran. And I go by the Slack handle Satya. That's my ZP channel, ZP Satya. I've been working in Mercari for 3 years now. So right from the beginning, I've been in the data space for since the inception that I've started here. And moving on to agenda. So we'll be starting off with a slideshow, which comprises of getting you familiarized with the BI concept and also a little bit on Looker. And the next 30 minutes and 30 minutes, like we'll be spending on data model creation, and another 30 minutes on data model and dashboard creation. And we'll keep it simple. We'll try to make you understand the BI domain as a whole, and make you understand why it is important, and also explore Looker models and the interface of Looker for you to get familiarized and bring the data modeling and visualization tool into everyday use in Mercari. So we're starting off. So as you already know, at this point, companies are dealing with several petabytes of data, which means like several thousands of terabytes. And the derivation of data, data can't be sitting there idle, and you'll need to derive the insights of the data, which is crucial. And for us to conduct the business investigations, we'll have to do it in a smarter way, so that we don't have any duplicated workflows. Also have to do it in a faster pace, and also based on the evidences that we get, our businesses should be directed based on that, right? So whatever product decisions that we choose, or um, whatever domain that we are trying to conquer, everything is based on the decision. And data is the fuel in the whole of the industry, right? So, and so the whole business is fueled by the data. All of the decisions and product decisions, everything depends on the data. So for us to have such for us to take such decisions on the data, we'll need to have the clean data stored somewhere, right? So, and it should be also easier to consume. Data should be democratic, should be accessible to everyone. So how do we do that? So all of these questions that we have will be resolved, will be addressed in this learning that we get out of the presentation. And BI is the answer. It's called, so BI stands for business intelligence. And so we are going to explore more on it. So what is BI capable of doing is that it's capable of answering the business performance problems. Like using the data, you could address the questions related to business. So, and also understand what the market looks like. For example, you need to know the KPIs that drives the market. KPIs are key performance indicators, like what's our current global merchandise value, how much are, like what is the um, average amount that a user of this age range is spending on, so that we can target those users, help them get those items that they want. These are the examples. And you should, it also helps us understand what's currently trending in the market and how do we address those supply and demand gaps. And also it helps us understand like the persona of the user and also the persona of the market, and helps us in deriving insights so that we can help the users to attain those um, things that they are trying to purchase in the markets and so on. And also help it also helps us in understanding those things that are missing in our marketplace, etc. Just a story. So back in the days, how was BI done? When I say back in the days, I'm talking about 10 years ago. When I started my career, BI was done mostly like there could be data lying in databases like MySQL, Postgres. Uh, so you might have learned about DBMS and everything, right? So data gets stored there, and people used to run sort of like reports. Like there will be someone called database administrator who just like has who just has the access to the database. And what happens is that they come to that person. I'm talking about the time when there were no data analysts, data scientists. Of course, there might be data analysts, but they will be reporting to the executives. So what happens is that we have the relational databases, and we have DB admins, and managers, and whoever does the business decision, they reach out to them to ask the question, like, I need some data like this, get me the results. So what this person used to do is that he writes SQL of his own, like a huge SQL of his own. And um, they either run it on the relational databases directly. It happened in a company that I used to work for, so they run it directly on the relational databases. Then we came into the picture and we were like, this seems wrong. So we need some sort of a data modeling on top of that. Then we created a data warehouse on top of this relational data that we had, like extracting them, storing them, and we gave that data warehouse to this DB administrator. So what they used to write is the huge SQL, like a SQL script, and they run the SQL script on top of the data, and they retrieve the results. They export the results to spreadsheet. Sometimes they export it to CSVs, and they upload it somewhere. And these people download it, right, and make Excel sheets and diagrams, graphs of it. So this is how BI was done back in the day. What I'm talking about is about 10 years ago, or probably 7 years ago. So all of those are driven by ad hoc reports. And also, if you work in fintech or banking related industries, uh, those executives require reports in an hourly manner. Like they need hourly reports every hour. They need to know what is the, it's kind of like the pulse of the market or pulse of the product. So they used to run the hourly report. They used to request for hourly. So hourly, we run the queries and we send email reports back to them. So they used to open their emails, understand like, okay, this is a pulse of the market, and they take the decision based on that. So this is how it was done back in the days. So is BI just about business reports? Is it just for businesses, or can it be expanded beyond that? Right? In reality, BI is just a mindset. So it helps anyone to take better decisions anywhere. And we also supports what's happening now, and also helps the machine learning engineers or analysts to predict what's going to happen in the future as well. So the scope is not limited to the current timeline, but beyond that. So if you take a look at it, some some teams might require the data to be in near real time. Those include fraud detection, logistics tracking, like for example, like money laundering cases or fraud detection cases. They need the data to be very fresh, right? And fresh data means that you spend more amount of money to on the computation resources and also the storage resources. And so if you plot it along hairline like this, cross hairline like this, you could see that the fraud detection and logistics tracking comes to the top right corner. And BI is like, the way I look at BI is that it lies on the sweet spot to the bottom left. So mostly deals with monthly, daily, and hourly reports. And also it's more like it's more about sales reports, marketing insights, and so on. And the BI setup lies on the bottom left quadrant over there. And the whatever you see on the top is like very business critical metric that they try to reach. And we are going to focus on the bottom left. To answer the question, does it have to be related to business? BI is not just about business, but it's something beyond that. So I would define like BI as better intelligence powered by data. So how do we reach that? So it's all about insight automation, right? So you put in raw data uh, on one side, you do the analysis on the other side, and then finally you gain the insights. And based on the insights, you get the users or business users can perform the action. It's to at the end of the day, it's to help whoever is trying to get insights out of the data. And how do we make that happen, right? And it's all about predictive analytics. It's more close to forecasting demand, fraud analytics, and anti-money laundering, and so on. And it could also be prescriptive insights, like what's going to happen in the future, like recommendations on what's the next feature that we can include in the application that we are building. And of course, we have embedded analytics to understand the pulse of the market. So putting insights directly into apps and workflows. So it's not just about business here. So what do we name it instead? So we could call it as data intelligence too. So instead of having it just focus on business, so we are using data to derive the insights out of it. So we might as well call it as data intelligence. So which other domains can data intelligence can help you? Like we have product to understand the features, like what sort of features can be added to the product, what sort of features can be added to retain the users using the product, and what sort of user journey that the user does the user go through. Are they facing any sort of difficulty in any of the pages and so on? So we like to understand like the whole flow of things, right? And when it comes to engineering, you could set up some some dashboards to monitor your service endpoints, like whether you're getting 200s, which is like okay status codes, or if you're getting a service unavailable request and so on. You could set up that, understand the latency of your APIs, etc. And of course, for marketing, when marketers run campaigns, they would like to know the success of their campaigns, or the how they can increase their campaign numbers, right? And also understand like what sort of revenue comes out of the campaign that they successfully done. And when it comes to operations, understand the supply chain logistics, like what's the supply versus demand gap, and whether all of the users are able to successfully receive their shipments and so on. Understand that. And when it comes to HR, internally they track hiring. They can track hiring. They can track the attendance. They can track the engagement, and even Dev Dojo that we are having right now, you can track your Docebo processing. It's amazing, right? So we have all of these fantastic data problems, and where do we find them, and how do we combat them, right? So the first challenge, whenever you apply, whenever you approach a problem, is to figure out what the business problem is. So you need to put up in kind of like writing a prompt, right? So you need to come up with some sort of like 3 or 4 sentences in which you can understand like what business problem you're trying to solve, so that you'll be easy to communicate with other people from other teams, or maybe it's your team. And we should also get the understanding of where our data is located, whether the data is available, and where it is located. So we need to locate the data sets and the tables, and understand like the next step would be to understand the schema, like whether you have all of the columns that you require to pull the information out from. And you should also know what sort of formulas you are going to apply to, and also understand like whether it requires any transformation. So if it's not in the form that you want it to be, you'll have to apply some transformation on top of it, which means as simple as converting temperature in Celsius to Fahrenheit. So we know the formula. We just apply the formula and we get the transformation. So that's how it works. Okay. So now I'm going to give you a perspective of how classically the whole ETL pipeline, or the whole data flow looks like. So operational data stores are nothing but um, relational data stores, which are like examples, MySQL, Postgres, and so on. And in modern terms, so RDS in AWS, Spanner in Google. And then we have analytical data stores, which are the data warehouses. In modern terms, Redshift. Uh, in Google terms, it's BigQuery. And when people build dashboards, or AI agents run SQLs on top of the analytical data stores, they use the universal communication language, which is SQL, right? Um, so writing SQL, it is tough. So that's where a lot of engineers and analysts come into play. Like they are well versed in SQL and they write SQL. Now AI is aware of AI has the context of SQL, and you can also use AI to write SQL. So when this is the traditional flow of data. So you have the operational data stores, and there are hourly ETL jobs or change data capture jobs that run to pull data from operational data stores to analytical data stores. And queries are run on top of analytical data stores. SQL queries are run on top of analytical data stores, and dashboards are run are running SQLs on top of the analytical data stores to pull the information. So we have 2 layers here. One is data layer, and the other one is AI/dashboard layer. So this is the whole traditional flow of data. What I'm about to show you right now is the modern flow of data, which has one extra layer in the middle, which is called a semantic layer. Now, please bear with me. We're gonna understand what that is. As you could see, there's an extra layer. So when dashboards or any dashboarding tools slash AI, they run query on top of it. Um, for for analytical data stores to understand it, this is sort of like a translational layer. So we'll get to the specifics of it. So just keep this diagram in your mind. So we have a data layer, a dashboard layer, and a semantic layer in the middle. BI is the modern BI is more about the semantic layer and the AI dashboard layer. So we get into the specifics of it. So let's understand what a semantic layer is. So when I say an elephant, what comes to your mind? An elephant, just an elephant. So he said Postgres. So yeah, but what comes to your mind when I say elephant? Jungle. Okay. So when I say elephant, an elephant pops up in your mind, right? So you're deriving a context out of the words that I say, right? That's exactly what a semantic layer is. So when I say an elephant, you picture an elephant in your mind, like it had like tail, trunk, it's huge in size, majestic, and so on. That's semantics. You're attaching a meaning to the symbol, right? So you know what an elephant is, right? So when I say so for for the database to understand whatever business context that I have, right? I'm supposed to communicate it with SQL, but if I'm a business user and I don't have SQL knowledge, it would be hard for me to communicate with the database, right? So the semantic layer solves that problem. Right? That's why it's called a semantic layer. Yeah, very vague, but yeah, it's what it does. So, for example, if we are a tech tech folk or someone who is dwelling in data, like who is in the data space, if I say TBL underscore USR underscore 001, just like naming a variable, if I say this, whoever is handling that data will know that this table contain the information about the users, right? But for a business user who's trying to solve a problem, if they are bringing the business problem, how will they know that TBL underscore USR underscore 001 is the table that they want? Right? If it's that the table that contains the information about the user. Or let's say the name of the table is like users, but the column names are like ORD underscore AMT. Now, from a technical perspective, we understand that this sort of like acronym means order amount. But from a business user's perspective, it's not clearly visible, right? So analysts don't have to speak in database language. They can speak in business terms. And semantic layer translates. So that's what the semantic layer is. Now you know briefly like why a semantic layer is required. So it is to convert the business definition into database language. And it doesn't just do the translation, but it also accelerates the in deriving insights. I'll tell you how it does it. And also, it can generate complex SQL queries. So imagine a business user coming with a business problem, and we are writing a SQL for them. And they say like, this SQL looks fine, but I need something else, right? In that case, you will have to start from scratch again, right? Rewrite the SQL, and it's an exhaustive process, right? And you're losing a lot of time reinventing the wheel again and again and again, right? And also the kind of analysis that they wish to do, for example, creating a pivot out of a table, right? So those require complex SQL skills, and all of the complicated things can be like a walk in the park when it comes to semantic layer. So you define the models, and the business users can drag and drop or just pick up those columns that they require, and semantic layer magically converts them to SQL queries without the help of AI programmatic. Um, Another example is that, for example, we have like a customer lifetime value. The business definition is customer lifetime value, but in database terms, we know that it's sort of like sum of the order amount of all the users in that table, right? So that's kind of like database definition. But when it comes to the business definition, it's more like customer lifetime value. That's it. And the analysts need to like they know this context. So the business users know that context, which is customer lifetime value and just revenue. Revenue is more like price multiplied by quantity. Price is a column, quantity is another column in the database table, and they just multiply both and they get revenue. Right? Business users don't need to write sequence, right? So they can simply pick those columns and they get the answers, right? So just a brief overview again for what the semantic layer is capable of. As you could see, the business user can ask the question like, give me a forecast growth for highest ACV customer segments last year by region. Use an area chart. So this is very descriptive. And semantic layer has all of the models that maps to all of the keywords that they have. For example, growth, it knows that it's a metric. So we define everything, and it has the context of which one to use, right? So what you see here is like a conversational analytics feature, which is an AI feature. So for this question to work, we'll need to define the models in the semantic layer like so. So we'll need to have all of these models like users, order items, inventory, products, so that all of the models and the corresponding dimensions to the models are present. And the AI is choosing the corresponding dimensions and measures and trying to come up with the visualization or the analysis on top of it. Now you understand what a semantic layer is. So what happened before a semantic layer used to exist, right? There were like raw SQLs everywhere. Like people used to write lots and lots of 1.SQL, 2.SQL, and so on. A lot of SQL files, SQL version 1, version 2, and so on. And I've done that. So in my first company, I used to have like folders and folders for each and every dimension that I'm trying to solve. It's like I'll be having a directory, and inside that directory, I'll be having 1.SQL, 2.SQL, and so on. So every single time they ask for some ad hoc reports, I'll have to find the corresponding SQL and just run it, generate it, and just give the data. And it's like that raw SQL everywhere. And so all of the analysts and teams, they'll have to write SQLs on the fly. So as I mentioned, the DBA problem, like people come to the DBAs and they submit the request, and the DBAs will write it on the fly for them, right? And if they want it from a different perspective, the DBA has to restart the whole process again. So it's like that. And also, there's like a large probability of having duplication errors, conflicting metrics as well. So another team might be having a different definition for a metric, and I'll be having a different definition of metric. There's no universal definition there, and that leads to conflicting counts, and that will lead to false marketing decisions or campaign decisions, and it could be a mishap, right? So we need to make sure that things are going smoothly. So after the semantic layer, it's more like going on the highway. So you have everything organized. So you have some raw data, and on top of the raw data, you build the data models, and then we'll be looking at what explores or what views are in a short while. So everything is organized in a semantic layer. That's the whole point. So which makes everyone use the warehouse effectively. Now, before we dive in, you might have attended some of the BigQuery related dev dojos just to refresh you what things are. So whatever you see here, uh, sorry about that. The first one is projects. So this is the BigQuery interface, and pretty sure you might have worked in similar. Have you worked in BigQuery? Like Darren's talk was there, right? So yeah, you might have worked in BigQuery. So you have projects, datasets, and tables there, and then you have each and every table has multiple columns in it. So this is what uh, a database table look like, and you know the components, right? Projects, datasets, tables, and the tables contain the columns. And just a brief overview of what a SQL is. So it's just a standard SQL, um, like a SQL script, where I'm trying to create a view. So the whole component is a view, and the sum of amount that you see here is called an aggregation, right? So it could be sum, it could be count, basic DBMS. So and you define joins there, of course. And when you use a subquery like this, it's also called as a common table expression. So a query can get complicated. So this is like a simple one, but can even go for 500 or 600 lines or even thousands, depending on what sort of problems you're trying to solve. I'd be happy to show you around during our demonstration. Yeah. So it can get messy, can get complicated. So now you understand the complication of writing a SQL. And just a brief overview of the Looker vocabulary. So at the end of the day, we want the users to generate their own SQLs, right? Dynamically generate their own SQLs. And the SQLs need to run on top of the data warehouse. And the way how we do that is the data analyst creates the data structures and the business rules. And how do they define those is sort of like in a configuration file. When it comes to software engineering, everything runs on configuration files. So we have a similar configuration file here, kind of like it's called LookML. So it has its own structure and it has its own syntax. But thankfully, these days, AI has helped people overcome that syntax related problems where you can generate your own LookML content with much more confidence. So you don't have to worry about the syntax now, but what you need to understand is that you define all of the models in a structure called LookML files, LOOKML files. So it has an extension like that. And uh, the Looker has an engine that is capable of generating SQLs out of these configuration files. So you choose those fields that are required from the file, and Looker can generate it for you. So the analyst or any data user in the company will write these configuration files so that the analysts and the business users can simply choose the ones that they require and generate the insights and aggregations out of it. So they don't only they not only generate the queries, but you can also apply filters to it and also create dashboards out of these the data that's present in the warehouses using the Looker models. And yeah, so that's shown here. So based on the data that you have in the data warehouse, you generate the Looker formatted results and visualizations. And now we also have capability of you can write prompts in AI, and AI will generate the results provided your data is clean and all of the models are present. So a little bit on LookML. So it is a modeling language. It's kind of like a configuration file, and it is a simple way of describing your building blocks of data models. And it's just like any other configuration file. You define it like parameter. uh, You have a parameter that's fixed, and value can be anything, right? So value can be whatever you define. So there are a little bit of bits like facts on the slides. So feel free to give it a view. So is anyone aware of YAML or JSON? Yeah, everyone's aware of it. Awesome. So this is more like YAML. So initially it was YAML, and then since it got more complicated and complicated, they came up with LookML, the structure of its own. But if you know YAML, you should be fine. And instead of defining the SQL, this is how we define, for example, a calculation. I was talking about a formula, right? For example, total revenue is like a sum of sale price in that particular table. And it's just an example to show you how to get the total revenue on top of a table, right? So you define the label is simple. You, this is the business definition that people need to know, like the business users need to know. And this is the communication to the database. Like this is the formula that we provide, like type sum, and the SQL is like on top of which column I'll need to run this formula, right? So on top of the sale price, I'll be running the sum, and that gives me total revenue. It's as simple as that. So behind the scenes, what happens is that this gets transformed into SQL, and you get a huge SQL out of it. And it knows, like, since you have defined like run this particular calculation on top of a table, it dynamically generates a SQL based on it. And for so just a little bit more syntax related things. So we have views, which is the table name. So table names are called as views in LookML. Just bear with me. It is confusing at first, but you don't have to worry about it. So all of your exercises have everything in place, so it should be fine. So views, the tables that you define in BigQuery are known as views in Looker. And the column names that you define in the tables of BigQuery or any data warehouse in that sense are called as dimensions. Okay. And the formula that you run on top of the tables, um, that's called a measure. Like you're trying to measure something out of the table. That's called a measure. Right? And we have the SQL logic using the SQL keyword here, SQL, and you define like dollar of table, which is to define kind of like a self table. Like, in this table, this is the column that you'll need to look at. And finally, the type. So type tells you what sort of a measure, whether it's going to be a measure or whether you're defining a dimension. So it's just to differentiate between the measure and dimension. So for now, just try to correlate like your views are tables, dimensions are columns, measures are the formula that you apply on top. Just remember these. Okay, so let me show you what the Looker interface looks like, right? Um, so this is the Looker interface that we have. We have so business users will use the explores that we create, which is the top left corner, the explore, and develop is where we are going to build the models today. And those are the dashboards. Whatever we build can be added to those directories so that anyone in the company can view it. And yeah, that's a restricted zone. You don't have access to it. So I don't have access either. So access denied. That's the admin panel. Yeah. And for you today to work on it, in your bottom left corner, you have a toggle called development mode. So when you're developing a model for anyone, you need to flip that switch, right, to the bottom left. Just remember that. I'll also guide you. And your development IDE is here, like the third button here. So Looker has its own built-in IDE. That is, it has its own code editor in Looker, and you can develop the LookML there. And so I was talking about generating the complex SQL, right? If you look at this, right, from a business user's perspective, you're giving them a tool for them to generate the SQLs dynamically. So based on your configuration that you built, they could get the dimensions and measures. So measures are the formula and dimensions are the columns. So business users can simply log in and they can drag and drop those things that they require. So for example, this is they drag like decade and season from the left corner, and they also drag measures from the bottom corner, right? And check this out. It dynamically generated a SQL, right? So business users don't have to write SQL anymore. And this is like an accurate SQL because you have defined the model beforehand. You have defined all of the views and exploits beforehand. So it's not prone to error, right? It's not like AI generating a bunch of code that's like hallucinated or anything. It's programmatically generated, so it's more accurate, right? So this is how we generate the complex SQL. Right. So this is a famous caption that I keep quoting from time to time. Keep looking up by Neil deGrasse Tyson. So let's explore some data models now.